My name is P. Chansi Nikita. I am studying BTech second year ECE in our college. Subject switching theory and logic design. My topic about counters in STLD. First, we have discussed what is counter. A counter is a device which stores the number of times a particular event or process has occurred, often in relationship to a clock signal. Counters are used in digital electronics for counting purpose. They can count specific event happening in the circuit. For example, in up counter, a counter increases count for every rising edge of clock. Not only counting, a counter can follow the certain sequence based on our design, like any random sequence 0, 1, 2, 3, and so on. They can be also designed with the help of flip-flops. These counters can be designed using flip-flops. Counters are sequential circuits that count the number of pulses, can be either in binary code or BCD form. The main properties of a counter are timing, sequencing, and counting. Counter works in two modes. Up counter, either down counter. Up counter means from 0 to increasing order of binary numbers 000 to 111, and down counting means from 11 to 000. That is the down counting purpose. Simply we can say counter means count the clock pulses in the clock signal, that is called counter. Classification of counter. It is divided into two categories of counters: asynchronous counter, synchronous counter. First we will see asynchronous counter. Asynchronous counter. In asynchronous counter, we don't use universal clock. Only first flip-flop is driven by main clock, and the clock input of rest of the following flip-flop is driven by the previous flip-flop. We can understand it by following diagram. First, asynchronous counter means clock signal is applied first flip-flop, that is the main clock, and next flip-flop is connected series of first flip-flop output QV is connected to the next flip-flop clock signal. That means series connection of clock is connected in asynchronous counter. This is the circuit diagram of asynchronous counter. It can be used in positive edge triggering to the clock pulses. This high means VCC is applied to this circuit, that is high. Clock signal is applied to the series combination in asynchronous counter. Clock signal is applied to the first flip-flop, that is the main clock pulse, and the next flip-flop can be connected to the clock signal. First flip-flop output Q is connected to the clock signal to another next flip-flop, and also next flip-flop output is connected to the clock to the next flip-flop, and another also it is connected to. These all are connected. Likewise, this series connection of clock pulses. It is called asynchronous counter. Here we can use positive edge triggering, means no bubble is there, that's why it is called as positive edge triggering. But here bubble is there, that is called negative edge. In this circuit, positive edge is used. It is connected to one power supply, that is high signal. The JK and JK are the two inputs. In asynchronous counter, Only J, K and T flip-flops are used because of these two flip-flops having toggle state means inputs both are 1 1. Next, timing diagram of asynchronous counter. First, clock signal is applied in this circuit. Likewise, Q0, Q1, Q2, Q3 are the outputs in these clock pulses. Positive edge in this clock pulses, negative edge is occurred. That's why negative edge is on and a positive edge is off. Likewise, 0, 0, 0, 0. This column is both are 0. Next, these clock pulses are on in positive edge only, but negative edge is applied to 0. Next, in this timing diagram, that Q0 is changing as soon as the rising edge of clock pulse is encountered. Q1 is changing when rising edge of Q0 is encountered. In this way, ripples are generated through Q0, Q1, Q2, Q3. Hence, it is called ripple counter and serial counter. Asynchronous counter is also called as ripple counter and serial counter. Means clock signal is applied series connection. That's why it is called as serial counter. A ripple counter is a cascaded arrangement of flip-flops where the output of one flip-flop drives the clock input of the following flip-flops. Means output is connected to the next flip-flop clock pulses. That's why it is called as cascade arrangement. Next, synchronous counter. The synchronous counter has one global clock which drives each flip-flop, so output changes in parallel. The one advantage of synchronous counter over asynchronous counter is it can operate on higher frequencies than asynchronous counter, as it does not have cumulative delay because of same clock is given to each flip-flop. It is called as parallel counter. In asynchronous counter, that is serial counter, also called as, but synchronous counter also called as parallel counter. Next, it is the circuit diagram of synchronous counter. In this circuit, JK flip-flop are used. JK are the inputs, Q and Q bar are the outputs. In these clock pulses, negative edge is used because of bubble is connected in these clock pulses. Q3, Q1, Q0, Q2 are the outputs produced in this clock circuit. VCC is applied to the supply. Next, AND gate is connected because of if both Q and Q bar are inputs are high, then only inputs are high. But Q1 is low, 1 is high, that is not connected to 0. That flip-flop is 0. In this circuit also similar to asynchronous counter. In this synchronous counter also timing diagram is used. Next, first we are giving clock pulses in this circuit. Negative edge is used, that's why it is on in the negative edge triggering, off on positive edge. Next, in these clock pulses, negative edge is on and positive edge is off. Q0, Q1, Q2, Q3 are the outputs counting purpose. Likewise, it is the up counting purpose, means 0 to 15 produced in this timing diagram. Negative edge is occurred, sorry, positive edge is occurred, that's why 0, 0, 0, 0. Next, negative edge is occurs, that's why Negative edge is on 0, 1, 0, 0, 0. Means 1 is activated in this timing diagram. Next, likewise, these all are seeing this counting purpose because of counters can count any clock pulses in this timing diagram. This is all about asynchronous counter and synchronous counter. First we will see what is asynchronous counter and synchronous counter. Next, circuit diagram of synchronous counter and asynchronous counter, and also seeing timing diagrams of these two asynchronous and synchronous counters. These synchronous and asynchronous both are used up counting, down counting, either positive edge or negative edge. We can use this asynchronous counter and asynchronous counter. This is all about counters. Thank you.